back. Determine the order and degree of each of the following differential equations. State also if they are linear or non-linear. So we want to solve these questions. Number one, we have solution. Solution is this. 1 plus the y the x all squared and everything raised to the power of 3 over 2 divided by the squared y the x squared is equal to k. So look at it. This exponent 3 over 2, we have to find way of eliminating it so that it will be in a polynomial form. So how do we do that? The first thing is that let's multiply cross multiplication. Let's do cross multiplication. So we have 1 plus the y the x squared, then everything raised to the power of 3 over 2 equals what? K multiplied by what? The squared y the x squared. So having done that, so the next thing is to square both sides. Square both sides. So squaring both sides gives, this one is cancelled. So we have what? 1 plus the y the x squared, then all raised to the power of 3 equals what? So we square this one, we have k squared, then multiply by what? The squared y the x squared squared. So now you can see that it's in polynomial form now. So since it's in polynomial form, you can now determine what? The order. Well, what's the order here? The highest derivative here is 2. So this is order 2. Order is equal to 2. It is ordinary differential equation of order 2. So what is the degree? Degree is the exponent of the highest derivative. So is it going to be this or this? Which one? So the degree will be the exponent of the highest derivative. So the degree is what? 2 as well. So let's look at this differential equation. Is it a linear or non-linear differential equation? Look at it. For linear differential equation, the maximum degree must be 1. But if you look at this one, you can see that the degree is more than 1. So the degree here is 2. The degree here, if you open it later, so it is more than 1. So this is not a linear but a non-linear differential equation. So it is a non-linear differential equation. So look at it. That is for number 1. Number 2. Number 2. The squared y the x squared equals 1 plus root of the y the x. So this one also is not in a polynomial form. So we have to write it in a polynomial form. So we need to do this. So the x squared equals 1 plus. This is what this means. The y, the x, everything raised to the power of 1 over 2. So we need to square both sides. Or before that, let this one come and meet this one. We have the squared y, the x, the y, the x squared minus 1 is equal to what? The y, the x raised to the power of 1 over 2. So square both sides. So if we square both sides, it's going to eliminate this root. So, continue. So from here we have the squared y, the x squared minus 1 all raised to the power of 2 is equal to what? The y, the x. So, we have eliminated the roots there. So, let's expand this one. So, it will give us the squared y, the x squared, then minus 2, the squared y, the x squared, then plus 1 is equal to the y, the x. So, it's in a polynomial form now. So, let's determine the order. What is the order? So, the highest derivative is what? 2. So, the order is equal to 2. What's the degree? Let's look at it. This is the highest derivative. So, it's also this one. But the highest exponent, the exponent here is what? 2. So, the degree is 2. So, when the degree is 2, is it a linear or non-linear? So, since the maximum degree here is not 1, so it is non-linear. So, the maximum degree is more than 1. So, non-linear. Here we have y is equal to dy dx plus c over dy dx. So, we need to simplify this. So then we now have y equals, let's find the LCM. So that will be dy dx. One in dy dx multiplied by dy dx, that will be dy dx squared. Then dy dx and dy dx is 1 multiplied by c, so plus c. So from here, we can now do the cross multiplying. So we have y multiplied by dy dx. So is equal to what? Dy dx all squared plus c. So from here, it is simplified now. So let's look at it. What is the order? You can see that the highest derivative here is 1. So the order is 1. Is equal to 1. So degree is what? 2. The higher, the exponents. So degree is 2. Okay, is it a linear or non-linear? So from here you can see that there's product of dependent variable with its derivative. So that's number 1 makes it a non-linear. And the other one is that the degree here is more than 1. That is another condition for what? Non-linear. So this is what? A non-linear differential equation. Non-linear. So I hope you understood everything. Number 4. This one is a straightforward question. So nothing complicated at all. Dy dx plus the square y dx squared is equal to 1 over 4y. So, what is the order? The order is what? That is the highest derivative. Order equals 2. What is the degree? You can see the degree is what? 1, because the power of the highest derivative is just 1. So, degree equals 1. Linear or non-linear? Look at it. The power, the degree is 1. It's not more than 1. That's first rule for what? For linear. Then there is no product of dependent variable with its derivative. So we can say that this is what? A linear ordinary differential equation. It's a linear differential equation. The 5th one. So you can see we have exponential of x, then y prime, prime, prime. I told you y prime, prime, prime is the same thing as what? The cubed y dx cubed. So is equal to exponential of y. Wow. So what is the order of this differential equation? The highest derivative here is what? 3. So this is order 3. So this is order 3. Degree is what? Degree is just 1 because the highest derivative has just 1 degree. So the degree is that's just 1 power. It's raised to the power of 1. Degree is equal to 1. Linear or non-linear? Okay, you said non-linear. Yes. Why? Why is it so? Because there is what? Exponential of dependent variable. So this is a non-linear ordinary differential equation. Non-linear. So please, I want you to go through everything. So if you have any question, please let me know in the comment section. Thank you. God bless you.